So in the previous class, we have found out the magnitude and direction of resultant vector, and we have also done numerical problems based on it. Okay, so today we'll start with polygon law of vector addition. Polygon law. The word polygon is for any closed figure. Yes, any closed figure can have any number of sides, right? Pentagon, hexagon. These are all polygon, triangle. Yes. So polygon law of vector addition means if we have a number of vectors, then how can we arrange those vectors to find the resultant? Okay. The polygon law is useful to find the resultant of a number of vectors graphically. We can find the resultant of vectors, a number of vectors graphically. Okay. So here, if a number of vectors are represented in magnitude and direction by the sides of a polygon taken in order, the resultant is represented in magnitude and direction by the closing side of the polygon taken in reverse order. Fine. So we have a number of vectors. Let this vector be v1, and this vector is v2. This vector is v3. This vector is v4. Okay. And this vector is v5. So we will arrange these vectors in such a way that they form a closed figure. So we have moved this first vector, and now we are going to move this second vector. Now third, fourth, and fifth. Okay, clear? So we have aligned these vectors. See, have you noticed one important point here? So अभी जो closing side है, closing side से will get a closed figure, and this closing side of these number of vectors is the resultant vector. Okay, this closing side is the resultant vector. So here V represents the resultant vector. Clear? And how do we write this resultant vector? As we have written for triangle law of vector addition, vector R is equal to vector A plus vector B. In the same way, here also we can write resultant vector B in terms of given vectors. Suppose this is vector A. Okay. And this is vector B. This is vector C. This is vector D. Okay. Now we have to find the resultant of these four vectors. So one thing we can note here that starting point of the second vector is the ending point of the first vector, where the arrowhead of the first vector is. Right? And at the arrowhead of the second vector, we have the starting point of third vector. At the arrowhead of the third vector, we have starting point of fourth vector. So we can say all these vectors are in order. These vectors are in order. So let's write this as vector A, this as vector B, this as vector C, this as vector D. If we consider only two vectors, the first two vectors, vector A and vector B only, if we don't consider all the vectors, let's consider vector A and vector B. Okay, so for vector A and vector B, we can draw the resultant by using triangle law of vector addition. We can draw the resultant. How do we draw the resultant? We start from here and we'll end at here. Okay, so this is the resultant of first two vectors. And we can write for this resultant vector, we can write, because this is resultant now, and vector R is vector A plus B. So we can write this vector as vector A plus vector B. Any doubt? Now look at these two vectors only, vector A plus vector B and vector C. Do not consider A and B now, not even D. Just consider these two vectors, vector A plus vector B and vector C only. Again, we can apply triangle law of vector addition here. Yes. So if we apply triangle law of vector addition, then we get another vector. Focus on these two vectors. Again, we'll draw another vector, and this represents the resultant vector of Resultant vector of A plus B and C. So we can write this vector as vector A plus vector B plus vector C. You can write like this. Any doubt? All right. Now let's take this vector now. A plus B plus C and vector D. Again, we can apply triangle law of vector addition. So on applying triangle law of vector addition, we'll get this vector. This vector is vector D. Sorry, A plus B plus C and D. We are considering these two vectors. No? So what is the resultant of this vector? This is A plus B plus C plus D. Okay, so we can write a resultant vector as vector A for four vectors as vector A plus vector B plus vector C plus vector D. Similarly, if we have n number of vectors, then we can write resultant of all those vectors in this form. Okay, please write this. This represents vector A. This is vector B. And this is vector C. Label these vectors first. We have vector A, vector B, and vector C. Now first find resultant of A and B. How will you draw the resultant vector for A and B? Draw the resultant vector first. For A and B, we can draw like this. Yes. So this represents the resultant vector of A and B. So we can write this as vector A plus vector B. Now draw the resultant vector of for two vectors, vector A plus B and C. The green one and the red one, maroon one. This one, this vector and this vector. How will you draw the resultant vector for these two vectors? Tell me. A plus B के starting से vector C के end तक, arrowhead तक. Okay. So this is the resultant vector. So we can write this as, yes. We can write this vector as vector A plus vector B plus vector C. Done. What if I take I choose B and C first, and then we can do like this. What if we choose B and C first and take the resultant and then take the resultant of A with A? Okay. Draw the vector now. Draw the resultant vector of vector B and vector C. What should be the direction? We'll start from this point of B and we'll end at the arrowhead of C, right? So this vector represents vector B plus C. Write B plus C here. And for A, A के starting point से B plus C के end तक, right? So where is the vector? This, the same vector, right? Look at the pink vector and the maroon vector. A vector A and vector B plus C. So when we draw the resultant vector, we get the same vector. This vector will point in the same direction. So what do we conclude from here? And we can write this vector as B plus C plus A. You can write A plus B plus C. Hardly matters. we're getting the same vectors like this. So conclusion क्या है इसका? क्या conclude किया आपने? क्या find out किया इससे? You'll get the same result. ठीक है? आप कहीं से भी start कर सकते हो polygon vector addition में. You get the same value of resultant vector. So in both the cases, we are getting the resultant vector as a plus b plus c only. So parallelogram law, previously we had done triangle law. Now we have parallelogram law. है ना? उसमें triangle form हुआ था. Two sides of triangle were the two vectors and the third side was the resultant. Okay, in parallelogram law, two sides are the vectors and resultant is the diagonal of the parallelogram. ठीक है? Triangle law में क्या होता है? Two sides are the given vectors and resultant is the third side. While in parallelogram law, we have two sides as the given vectors and we take resultant as the diagonal of the parallelogram. Okay, so this is the statement of parallelogram law of vector addition. So if two vectors of same type acting simultaneously at a point are represented in magnitude and direction along two adjacent sides of a parallelogram, then their resultant vector is represented in magnitude and direction by the diagonal drawn from the same point. Okay, so if we have two vectors, vector p and vector q, so you can see the initial point of both the vectors are coinciding. So we can say that they are co-initial vectors. Vector p and vector q are co-initial vectors. Their initial points are coinciding. They have the same initial point. है ना? So if the two vectors have the same initial point, then we represent resultant vector as the diagonal of the given vectors. Triangle law of में और parallelogram में क्या difference है? In parallelogram law of vector addition, we had taken the vectors in such a way that ending point of the the arrowhead of the first vector was coinciding with the initial point of the second vector. So if arrowhead of the first is coinciding with the initial point of the second, then we apply triangle law of vector addition. But if two vectors have the same initial point, if the two vectors are co-initial, then we apply parallelogram law of vector addition. Okay, you will get the same value of resultant vector as vector r is equal to vector p plus vector q. But this vector r passes through the middle of the vectors and it represents the diagonal of a parallelogram. If we stretch this and form a parallelogram, then it's like diagonal. So how do we derive parallelogram law of vector addition? Derivation is the similar derivation as we had done for triangle law of vector addition. The same way we can do for parallelogram law of vector addition. So let vector p and vector q be two vectors having angle theta between them. When we consider the vectors, we represent the angle between the vectors as angle theta. In triangle law of vector addition, we had taken the same angle theta. Here also we're taking the same angle theta. It is the angle between the given vectors. Yes, it is the angle between the given vectors, vector p and vector q. So vector r represents its resultant. But for this, we need to draw the parallelogram first, because only then we can draw the diagonal to show the resultant vector. Okay, so this ABCD represents the parallelogram. So we have only, we had the vectors, the two sides of adjacent sides of parallelogram. So if we have two adjacent sides, we can draw another pair of adjacent sides, because sides are equal and parallel. So we can draw like this. So AD is parallel and equal to BC and AB is parallel and equal to DC in this parallelogram. So complete parallelogram, this is a complete parallelogram ABCD, and let vector AC is equal to vector R be the resultant vector. Okay, so this represents the resultant vector. And this R makes an angle alpha with the first vector. And it makes an angle alpha with the first vector. In triangle law of vector addition, we have taken the same notation. With first vector, resultant vector was making angle alpha, and with second vector, it was making angle beta. So here also we are taking the same notations. Okay, so there is no difference. Now we will construct CE perpendicular to AB. We'll extend the line AB to E and draw a perpendicular CE. on it. The angle is the theta, the same angle. Why? Corresponding angles, because AD is parallel to BC and therefore these two angles are equal. These are the corresponding angles. So we can apply Pythagorean theorem. AC square can be written as AE square plus EC square, as we have applied in triangle law of vector addition. We can write AE as it's AB plus BE. So we can write it as this as AB plus BE whole square plus EC square. Okay, so this is equal to A plus B square. We'll apply the identity, algebraic identity here. We'll get this. AB square plus 2AB dot BE plus BE square plus EC square. This AB square is P square. And BE square is, if we resolve this Q into components, and BE square plus EC square is, we can write like this also, no? BE square plus EC square. Look at the smaller right angle triangle. We have right angle triangle BCE. In this right angle triangle BCE, BE square plus CE square represents the perpendicular and base of the triangle. This is equal to BC square. No? This is equal to BC square. And BE. What about BE? BE can be written as BC cos theta. We have simply resolved this vector into, we can write, the base and the perpendicular in terms of sin theta and cos theta. So CE can be written as BC sin theta and BE can be written as BC cos theta. We can write like this. And CE is BC sin theta. Perpendicular upon hypotenuse is sin theta. No? Perpendicular is CE. Hypotenuse is BC. Yes, so CE upon BC is sin theta. And BE upon BC is cos theta, base upon hypotenuse. So we can move this BCs to the other side and we'll get the values, expressions for BE and CE. Okay, ये here. Now we can further write this AC square as, we can write BE as BC cos theta. So in place of BE, we have written BC cos theta. And in place of BE plus EC square, we have written this BC square. Okay. Now, because AC is the resultant vectors, we'll write R square is equal to AB is P square. 2 into AB is P, BC is Q cos theta, plus BC is Q square. So this is the magnitude of resultant vector. Okay. And we can write this as in square root form. यहाँ पे square है, वहां जाके square root हो जाएगा. Yeah. Please write this. Done. From triangle AEC. Look at this triangle. What is tan alpha? AEC may apply this relation. Tan alpha is perpendicular by base. Perpendicular is CE and base is AE. So it's CE by AE. What is CE? It's BC. BC cos theta नीचे होता है. BC sin theta. Cos theta कब होगा? जहां पे राइट एंगल और थीटा एंगल दोनों साथ में होते हैं. उस साइड को हम cos लेते हैं. This is CE upon AB plus BE we have written here. Now we will write for BE. BE is BC cos theta and CE is BC sin theta. Okay, so we can further write this as this. And BC is Q. So it's Q sin theta and AB is P plus BC is Q. So Q cos theta. Okay. We have got the same relation as we had done in triangle law of vector addition. Yes. So we can write alpha as tan inverse of Q sin theta upon P plus Q cos theta. So alpha is the angle between the resultant vector and one of the vectors, given vectors. And theta is the angle between the given vectors, two vectors that we have. And alpha is the angle between the resultant vector and one of the vectors which are given to us. So we have these two vectors, vector P and vector Q. Angle between the vectors is theta. We formed a triangle. R is the resultant vector. Alpha is the angle between resultant vector and vector P, and theta is the angle between the given vectors. So when two vectors P and Q are added, the resultant vector will have a magnitude this. R is equal to square root of P square plus Q square plus 2PQ cos theta. Theta is the angle between the given vectors P and Q. And the resultant vector makes an angle with respect to the side AB, as alpha is equal to tan inverse of Q sine theta upon P plus Q cos theta. So these are the formulas. Special cases. So what if theta is 0 degree? If theta is equal to 0 degree, then both the vectors will point in the same direction. They are called parallel vectors. Put the value of theta as 0 degree and find R and alpha. Do it. Do it. Cos 0 degree is 1. So it's P square plus 2PQ plus Q square. It's P plus Q whole square. Answer is the sum of the two vectors. See, here we are adding the magnitudes of the vectors. We are not taking this as vectors. यहाँ पे कहीं पे arrow दिख रहा है आपको? Because this represents magnitude of R, and P square and Q square represents magnitude of P and Q respectively. Okay, so if cos 0 degree is 1, so it becomes 2PQ only, and we can apply the algebraic identity here, A plus B square. So we get this. So we'll simply add the magnitude of the two vectors if they are parallel. Okay. And what about the angle? Yes, because sine 0 degree is 0, so tan alpha is 0. And what is the value of alpha? It's 0 degree. So resultant vector क्या होगा? If two vectors are parallel, तो resultant vector भी उनके same direction में होगा, aligned, है ना? Done. Done. Next. What if theta is 180 degree? If the vectors are anti-parallel vectors, they are pointing in different directions. Angle between them is 180. Cos 180 is cos 180 minus 0. It's minus cos 0 degree. Cos 180 degree minus 0 degree क्या होता है? Trigonometry करवाई थी ना? Mine आपने नहीं की थी. आपने नहीं की मेरे पास. आपको आती है? Basic trigonometry. गर्व आपको नहीं आती. Cos 180 minus 0 is minus cos 0 degree. So we write minus 1. Okay. R is under the root of P square plus Q square plus 2PQ cos 180 degree. So we'll write for cos 180 degree minus 1. So we'll get P square plus Q square minus 2PQ. It's P minus Q whole square. We'll simply subtract the vectors to get the resultant vector. Similarly, we can find the angle between the resultant vector and one of the vectors. Sine 180 minus 0 is sine 0 degree. Sine 180 minus 0 is sine 0 degree. Sine 0 degree is 0. Yes. But here we have a condition. See, if we take, because tan alpha is 0, we had cos 180, we had taken cos 180 degree and sin 180 degree, right? इसमें तो कोई प्रॉब्लम नहीं है. अब जो हमारा tan alpha है वो 0 आएगा, because sin 180 is 0, tan alpha is 0. tan alpha is 0 is at alpha equals to 0 degree. It is 0 at alpha equals to 180 degree as well. Here we have a condition. Alpha is 0 degree if P is greater than Q and alpha is 180 degree if P is less than Q. इसका मतलब समझा दो मुझे बस. Tell me. बताओ. So this is P and this is your Q. Q is smaller than P. P is greater. So give me the direction of the resultant vector. Towards P, but smaller in magnitude. No? Towards P, but smaller in magnitude. Right? This is the direction of resultant vector. Now tell me. And if we consider, let's take another situation that we have vector P smaller and vector Q greater. Now what? Vector Q greater. Now, what is the direction of the resultant vector? It is towards Q, but smaller in magnitude. Because minus करेंगे ना उसको. Right. अब बताओ मुझे. Can you explain this fact now? ये आपका वेक्टर P है and this is your vector Q. Vector P, vector Q. Here we have this direction as the direction of resultant vector and here we have this direction as the direction of resultant vector. So we are getting different directions. So it depends upon the magnitude of the given vectors. Right? So alpha is 0 degree if P is greater than Q. Because see, we are measuring angle from P to Q. When we measure angle theta, we measure it from P to Q. No? We take P here and Q here and we write this angle as theta. Right? The angle between the given vectors is theta. So this angle is 180 degrees from P to Q. It goes like this. This angle is 180 degree. And here also we have the same angle, no doubt. This angle is the same. It's 180 degree only. But the difference is if P is greater than Q, then we are taking alpha as 0 degree. Then alpha is pointing in the same direction where P is. So we are measuring, see, what is this angle alpha? This angle alpha is the angle between vector P and the resultant vector, vector R. Again, we are measuring angle from, this is vector R and this angle is theta, no? Alpha, sorry. Again, we are measuring angle from, tell me, P, no? Because this angle, we have taken alpha as the angle between vector R and vector P only. So here, angle between vector P and vector R is 0 degree. They are pointing in the same direction. So here alpha is 0 degree. But when Q is greater, then R is pointing in the opposite direction. Now the angle between P and R is 180 degree. So if P is less than Q, then angle is 180. And if P is greater than Q, then angle is 0 degree. I hope this is clear. What if the vectors are mutually perpendicular vectors? If theta is 90 degree, then wait. We can write the magnitude, the same formula. Put cos 90 degree. Cos 90 degree is 0. So we'll get R as under the root of P square plus Q square. This is the resultant vector. Similarly, we can find direction. Again, it's Q sine 90 degree upon P plus Q cos 90 degree. Sine 90 degree is 1 and cos 90 degree is 0 degree. So we can write tan alpha as q into 1 upon p plus q into 0. तो vanish हो जाएगा, तो it's q upon p only. Write this. Done. Now we have questions based on this. So if p plus q is equal to r, vector p plus vector q is equal to vector, then vector r is always greater than vector p. Vector r is equal to, always equal to vector p plus q. Vector r is never equal to vector p plus q. Vector r may be less than vector p or vector q. Next question. The maximum and minimum resultants of two forces are in the ratio 4:3. The forces are in the ratio 7:1, 1:5, 4:7, and 3:7. Maximum resultant, how do we find maximum resultant? When we take angle between the vectors as 0 degree. And how do we find minimum resultant? By taking angle as 180 degree. Okay. F max and F min is given. Ratio is given, no? Maximum and minimum resultant ka ratio given hai. The forces are in the ratio. We have to find the ratio of the forces given vectors. Do it. This is how we find maximum resultant and minimum resultant. Their ratio is given. F1 plus F2 upon F1 minus F2 is 4/3. We have to find the ratio F1 upon F2. F1 को one side में move कर लो, F2 को other side में move कर लो. You can simplify it. You will get the ratio 7:1. Option 1. Next question. If two vectors have magnitudes in the ratio 5:8, the results have maximum and minimum magnitudes in the ratio 13:3, 3:1, 8:5, 6:5. We have two vectors, their ratios is given. Now it's F1 by F2 is given, we can say, or A by B is given. मेरे को देखते ही इसका आंसर पता लग गया. P by Q is given, it's 5/8. So we can write Q as 8P by 5. So it's 13/3. Next question. अच्छा. P and R is the resultant vector. It is perpendicular to the smaller one. We have two vectors, 2P and P. है ना? Two forces है. One double the other in magnitude. एक दूसरे का double है. And resultant is perpendicular on the smaller one. So this R is perpendicular on the smaller one. We have to find the angle between the two forces. ठीक है? P by 2P क्या है यहाँ पे? ठीक है, sin theta is half, तो theta is 30 degree, तो 90 plus 30 is 120. तो ये टाइम सेविंग मेथड है. ठीक है. यूजुअली हाउ चिल्ड्रन डू दिस क्वेश्चन. कैसे करते हैं बच्चे, कैसे करते हैं इस क्वेश्चन को जो अटेम्प्ट करते हैं यूजुअली? ये देखो, ये तो इजी वे है, बिकॉज अगर हम इसको थीटा ले रहे हैं इंस्टेड ऑफ टेकिंग दिस एंगल एज थीटा, तो वी कैन अप्लाई पाइथागोरस, दिस आइडेंटिटी हियर, sin थीटा इज p upon h, है ना? सो इट्स हाफ, तो थीटा इज 30, तो वी कैन ऐड 30 to 90, विल गेट 120. इजी. ठीक है. इसके अलावा क्या कर सकते हो? हाउ डू वी राइट tan alpha? Tan alpha is b sin theta upon a plus b cos theta. क्लियर है? अगर हम ये मान के चलें कि हमारा जो b है वो डबल है, मतलब ये a है, ठीक है, and this is your resultant vector, vector R, and this is the third vector, vector B, and this resultant vector is perpendicular on the smaller vector, and this smaller vector is half of the bigger vector. So we can write B as 2a. This is given. And what is this angle? The angle which resultant makes with the first vector, one of the vectors, is alpha. And this angle, the angle that we have to find out is theta. This is how we take the, ऐसे तो लेते हैं. So we can write 1090 degree is equal to, because B is 2a, so it's 2a sine theta upon a plus, for B we'll write 2a again, 2a cos theta. ठीक है. What is 1090 degree? 1090 degree is not defined, infinite. We can write 1090 as 1 upon 0 is equal to 2a sine theta upon, we can take a common, in the bracket we will have 1 plus 2 cos theta. a से a कैंसिल हो जाएगा, क्रॉस मल्टीप्लाई करोगे ये वाला आपका 0 हो जाएगा, and now we have 1 plus 2 cos theta is equal to 0. Any doubt? Any doubt? No? So we can write cos theta as minus half. Theta, cos theta is half at half, positive half. At sine 30 degree is half, now it's cos 60 degree. We put a negative sign. Minus cos 60 degree can be written as cos 180 minus 60 degree. So cos theta is equal to cos 180 minus 60 degree. This implies cos theta is equal to cos 120 degree, and therefore theta is equal to 120 degree. So this is another way of finding the angle. Next question. The resultant of vector P and vector Q makes an angle alpha with vector P and beta with vector Q. Alpha is less than beta. Then if P is greater than Q, P is less than Q, P is equal to Q, all of the above. सोच के बताओ. आंसर जल्दी दे दिया. अच्छी बात है, क्विक रिस्पॉन्स, बट सोचो थोड़ा सा. Alpha with P and beta with Q, alpha is less than beta. अगर अल्फा बीटा से कम है तो कौन सा वेक्टर बड़ा होगा P और Q में? अल्फा वो एंगल होता है which resultant vector makes with the first vector, and beta is the angle which resultant vector makes with the second vector. इस बेसिस पे P greater than Q बोलते हैं. और कुछ मैथमेटिकली आप इसको प्रूव कर सकते हो. is equal to P upon is equal to Q upon, क्या लगाया? is equal to P upon sin सी बीटा लेंगे क्योंकि बीटा आर और क्यू के बीच में एंगल है, और क्यू के नीचे वो एंगल लेंगे जो आर और पी के बीच में है, अल्फा. दिस इज हाउ वी टेक, राइट. बीटा एंगल किस में है? आर और क्यू के बीच में, राइट. तो आर और क्यू के बीच में जो एंगल है वो पी के नीचे लिखेंगे, और अल्फा एंगल है आर और पी के बीच में, जो आर और पी के बीच में एंगल है वो क्यू के नीचे लिखेंगे, और थीटा एंगल है बिटवीन पी एंड क्यू, तो उसको आर के नीचे लिखेंगे. यहां से ट्राई करो. It's P upon sin beta is equal to Q upon sin alpha. So it's if alpha is less than beta, देन सी साइन थीटा की जो वैल्यू होती है, साइन थीटा की वैल्यू जो होती है वो कैसे जाती है, वो इंक्रीज करती है ना। साइन 0 डिग्री पे 0 होता है, 30 डिग्री पे हाफ होता है, इट्स वैल्यू इंक्रीजेस, 1 तक इंक्रीज होती है। ऑसिलेट ऐसे तो ऑसिलेटिंग होते हैं साइन को साइन, ठीक है। बट 0 to 1 में अगर हम देखें तो इंक्रीजिंग साइड में जाता है। इफ यू इंक्रीज द वैल्यू ऑफ थीटा देन वैल्यू ऑफ साइन थीटा आल्सो इंक्रीजेस, है ना। तो अगर आपका अल्फा स्मॉलर है बीटा से, तो साइन अल्फा वुड बी स्मॉलर देन साइन बीटा। रेशियो इक्वल कब आते हैं? these two ratios are equal ना। so if we are taking this as 3/6 and this as 1/2, अगर आपका अल्फा स्मॉलर है तो क्यू भी स्मॉलर होगा, और अगर आपका ये बड़ा है तो ये भी बड़ा होगा। नहीं आया? 3/6 1/2 के इक्वल होता है। अगर आप 4/8 भी कर सकते हो, तो अगर आप न्यूमरेटर को इंक्रीज कर रहे हो तो अकॉर्डिंगली आपका डिनोमिनेटर भी इंक्रीज हो रहा है, तभी रेशियो इक्वल आता है। हाफ तभी आता है ना। तो अगर आपका अल्फा स्मॉल है तो क्यू हैज टू बी स्मॉलर। अल्फा स्मॉल है, इट इज गिवन, so q has to be small. If modulus of vector p plus vector q is equal to modulus of vector p minus vector q, then the vectors p and q are parallel to each other, inclined to 45 degree at 45 degree to each other, perpendicular to each other, inclined at 60 degree to each other. Give me the answer. Curve. आप भी आंसर कर सकते हो. Try this. Vector p plus vector q is equal to vector p minus vector. तो दोनों वेक्टर्स कैसे हैं? पैरेलल हैं, इंक्लाइंड एट 45 डिग्री है, इंक्लाइंड एट 60 डिग्री है, परपेंडिकुलर है। कैसे कैसे फाइंड द आंसर? यस हर्ष। क्या किया हमने? फर्स्ट वी हैव टेकन द वेक्टर्स p एंड q, वेक्टर r वुड बी p plus q, है ना। देन हमने q को डायरेक्शन रिवर्स कर दिया, पहले अपवर्ड था अब डाउनवर्ड कर दिया, तो q विल बिकम माइनस q नाउ ना, एंड रिजल्टेंट विल बी r minus r is equal to p minus q. So vectors are perpendicular to each other. Yes. R is equal to under the root of a square plus b square plus 2ab cos theta होता है, ठीक है। ये आपका a प्लस बी कब आता है? जब cos 0 डिग्री 1 होता है। तो इसमें आप क्या करोगे, ये p प्लस क्यू मैग्नीट्यूड ले रहे हो आप इसका, तो ये आपका r क्या है? वेक्टर r होता है, वेक्टर r is वेक्टर a plus वेक्टर b, and if we are considering magnitude then we write r as modulus of vector a plus vector b. So modulus of vector a plus vector b is under the root of a square plus b square plus 2ab cos theta. Similarly, if we have a vector r as vector a minus vector b, है ना, a minus b ले रहे हैं अगर हम, then we write modulus of r, magnitude of r as modulus of vector a minus vector b, and here we write square root of a square plus b square minus 2ab cos theta. Now this thing is given ना, these two are equal, तो ये भी इक्वल होंगे, है ना। we have taken A and B in place of P and Q, we have taken A and B, कुछ फर्क नहीं पड़ता उससे। तो मतलब इसकी जगह पे हम A ले रहे हैं और इसकी जगह पे हम P ले रहे हैं, B ले रहे हैं, क्या फर्क पड़ता है। तो अब आपका देखो यहाँ पे जब आप इक्वेट करोगे तो क्या आएगा, a स्क्वायर प्लस बी स्क्वायर प्लस 2ab cos थीटा इज इक्वल टू a स्क्वायर प्लस बी स्क्वायर माइनस 2ab cos थीटा। दिस implies 4ab cos theta is equal to 0. Theta 0 कब होता है, 90 degree. Write the solution. Next, the resultant of two forces of each magnitude f acting at a point is root 2f. What is the angle between the vectors? फर्स्ट कैसे करोगे, each of magnitude f, f1 is equal to f, f2 is equal to f, रिजल्टेंट क्या आएगा, r is equal to square root of f square plus f square plus 2f square f1 f2 cos theta, f1 square plus f2 square plus 2 f1 f2 cos theta होता है, right? For f1 and f2 we are writing f square plus f square plus 2f square cos theta, and this is equal to root 2f. So we can write, because resultant is root 2f na, so it's 2f square, in the bracket we will write 1 plus cos theta, square root में आ जाएगा, is equal to root 2f. Squaring both sides, we get 2f square is in the bracket 1 plus cos theta, and here it's 2, root 2 becomes 2 and f becomes f square, 2f square cancel. So now we have 1 plus cos theta is equal to 1. This implies cos theta is equal to 0 and theta is 90 degree. This is how you have to write the solution for this question.